Welcome to part 2 of our 3-part botnet adventure. I'm Corey. In our last video, I showed you how an evil bot herder creates a botnet from scratch. This video shows botnet attacks, and part 3 will show you how to defend against bots. Some folks say a botnet is the Swiss Army knife of online crime. Why? Well, let's watch our made-up bot herder, Spike, whip out some of his Swiss Army blades. You'll see why a botnet is the ultimate blended threat. Bot masters commonly use their botnets for an attack called a distributed denial of service, or DDoS. In a DDoS attack, the bot master overwhelms a victim computer by sending it huge amounts of network traffic from many bots, often spread out geographically. My magic whiteboard shows an overview. Suppose you run an online store. Some bot herder notices your success and decides he wants a piece of it. He sends you an email saying, "Send me 3,000 or I'll knock your online store off the web." You refuse, so the bot herder commands his zombie army to start sending HTTP requests to your online store. But each bot doesn't settle for one HTTP request. Instead, they each send as many requests as they can, as fast as they can, saturating their network connections, for as long as the bot herder wants. Thus, your normal customers are denied whatever service your website offers. How bad can a DDoS get? A bot herder controlling a meager 1,000 broadband-based bots can combine them to create approximately 250 megabits per second of network traffic. That's more than enough to clog up an OC3 network. Since this deluge of traffic comes from many computers at many different locations, it's hard to block. An average SMB network couldn't function under this much load, so the bot herder could effectively take your online store offline. For example, in 2004, a bot herder with 10,000 bots knocked DoubleClick and Akamai offline for hours. How hard is it for a bot herder to organize this type of coordinated attack? If you ask Spike, not hard at all. Using his CNC, Spike logs into his bots. His RxBot variant offers a few different types of DDoS attacks: a ping flood, a SYN flood, a TCP flood, and a UDP flood. These different DDoS attacks generate different types of network traffic, but they all work pretty much the same. For instance, if Spike wants to flood your web server with HTTP SYN packets for 10 minutes, he sends his bot this command. Now his bots are sending your web server a flood of pointless HTTP traffic. Using a packet sniffer, we can see the sheer amount of packets this simple command generates. Notice, RxBot even randomizes the source address of each packet, hiding where this attack really comes from. Spike could easily choke your web server for hours with a moderately sized botnet, and this DDoS is just one example of a botnet attack. If you're a network administrator and you're squeamish, you don't want to see what else Spike does. Next. We've looked at bots attacking you, but what if a computer on your network is a bot? What could Spike do to your zombied computer directly? In short, anything you can imagine, and a lot you probably haven't imagined. For example, bot herders can turn a bot-infected computer into a file server that hosts illegal, pirated software. Or Spike could transform your PC into a web server that masquerades as a legit banking site. He can even enable network services that give him command line control of your PC. Let's see how Spike does that. He begins with a service called rlogin. Rlogin is very similar to Telnet. It enables a bot herder to connect to a remote computer and send commands. Since rlogin is built into RxBot, Spike can easily start an rlogin server on any of his bots. First, he starts a private chat with the one bot he wants to command. He could turn on the rlogin server for all his bots at once, but he only wants to control one for now. So he sends that bot a command to turn on its rlogin server. There, the bot replies telling Spike its IP, username, and rlogin port. To connect to the bot's rlogin server, Spike needs an rlogin client. PuTTY is a universal client that supports several services including rlogin. It's free, so that's what Spike uses. In PuTTY, Spike chooses rlogin connection. He enters the bot's IP and rlogin port. Then he enters the rlogin username and clicks connect. There we go. Spike has command prompt access to his bot. The level of control he has over this specific bot depends upon which exploit RxBot used to infect this computer. Using the whoami command, Spike sees that he has full administrator access to this PC. He can do anything he wants. For instance, he can change the administrator password so that he can access the computer and its real owner cannot. Youch! If one of your computers gets infected with the bot, its master could have full control of that machine. Could it get worse? Sure. Spike can also watch everything you do. He'll show you how next. RxBot offers several ways to spy on its victims. It can keylog, packet sniff, capture screenshots, and if the victim runs a webcam, even capture audio and video. Let's watch Spike try a few of these spying features. Here's the keylogger. To keep things simple, Spike only logs the keystrokes of one bot for now. After opening a private chat with that bot, he sends it this command. Now this bot will report all its keystrokes to Spike's CNC channel. Let's switch to the victim's perspective. Sarah, a receptionist, is transcribing notes and Word from some meeting. Bored, she decides to check her Gmail account to see if her boyfriend has sent any funny YouTube videos. Nope, nothing interesting. Back to transcribing. Uh-oh, nature calls. Sarah locks her workstation and leaves her desk for a few minutes. When she returns, she logs back in and continues transcribing. Everything's normal here. Wonder what's happening on Spike's end. Wow, Spike's bot returned a lot of keylogs. There's Sarah transcribing her notes. Now we see her opening Internet Explorer. Then she went to Gmail and look at that. There's her Gmail username and password. Now here's Sarah logging back onto her computer. Yep, we have her Windows credentials. A few more days of this and Spike can know everything about Sarah and a lot about the company she works for. That's not all he can log. If he sees something interesting during a keylog session, Spike could snap a screenshot of Sarah's desktop to see it in more detail. Let's watch. Here's the command to capture Sarah's screen. The bot saves the screenshot locally, so Spike needs to download it. He uses RxBot's handy get command. This tells the bot to use IRC's file transfer to send the picture to Spike. Here it comes. Now we can see what Sarah sees. Using a similar command, Spike captures a single frame from Sarah's webcam with her completely unaware. He downloads the image again, and there's Sarah. Spike could even capture video if he wanted. Spy attacks like that are flashy, but they're not the main use of bots. Botnets are primarily used for cache. I'll show you Spike's get-rich-quick scheme coming right up. Besides all the nasty stuff you've seen so far, RxBot also allows Spike to install anything he wants on his bot's machines. It also provides a convenient way for him to upgrade his bots to the latest and greatest version. Watch how these two features work. Let's say some internet advertiser hosts web ads. If you posted the link that a person clicks on to get to the ad, you get a few cents for every click. Well, RxBot comes with a command that allows Spike to download and install new programs on all his bots at once. So he gets an adware app that forces his victims to visit web ads. If he hosts this malicious app on some website and then commands all his bots to download and install it, his 1,000 bots start clicking automatically on paying ads, earning money while Spike runs off and plays. So where does Spike host his malicious app? Duh, on another bot. He uploads his evil app to any bot he wants. Then he sends a command to that bot telling it to act as a web server. Now he has a website where all his other bots can get his adware surprise. Next, Spike commands his bots to download the newly hosted adware using this command. The first parameter tells his bots what URL to download the adware from. The second parameter tells the bots where to save the file once downloaded. And the one parameter is a switch that tells the bots to execute the program after downloading it. Now all Spike's bots are running his adware, thus generating income for him. He could just as easily use this command to install new malware on his bots. Plus, he can use a similar command to upgrade his bots with the latest and greatest botnet code. If he adds any neat new attacks to his bot source, here's how he updates his bots. Spike types update followed by the URL that has a copy of his new bot. The last parameter is the bot ID, found in the bot source code. His bots will only install the updated code if their ID is different than the ID they currently run. This single command makes all the bots go out and receive their update. It's almost as easy as Windows Auto Update. Scary, eh? So far, our imaginary bot herder has used his botnet to extort businesses and knock them offline. He's gained unrestricted command line control of his bots. He's spied on his bot victims both virtually and physically, and he's earning free money with automated ad clicks. Believe it or not, these attacks merely scratch the surface of a botnet's malicious potential. For more botnet attacks, check out our supplemental botnet attacks article in the Live Security Archive. Now you know why botnets are a hacker's Swiss Army knife. Essentially, once a bot herder infects your PC, he can do anything on it he wants. Multiply this potential by thousands and thousands of bots, and you have one insanely scary threat lurking in the shadowy corners of the internet. But don't panic. In part 3 of this malware analysis series on botnets, I'll show you how to detect this threat and protect against it. Don't miss our next video.